DOSAAF-85 RS-44 is an amateur radio satellite with a linear transponder SSB/CW. RS-44 was launched in December 2019. It is a VU satellite with uplink from 145.935 to 145.995 MHz and downlink from 435.670 to 435.610 MHz. The transponder has 60 kHz bandwidth. It has an inverting transponder, meaning that uplink is on LSB and downlink on upper sideband. It is fully operational with a lot of DX communications going on. Unlike the FM satellites, SSB satellites have higher bandwidth, which allows multiple stations to have QSOs at the same time. RS-44 has an elliptical orbit with a perigee of 1175 km and an apogee of 1511 km and an inclination of 82.5 degrees. The onboard radio has 5 watts power output and there is a beacon which transmits CW call sign RS-44 at 435.605 MHz. If you have a look at the AMSAT live Oscar satellite status page, you can see that it is uniformly active with numerous status reports. I am trying to listen to the beacon of RS-44. You can see that in the polar map, the satellite is here. The elevation is about 34, that is the maximum possible in this pass, I think, and almost maximum. This is an eastern pass, and you can see that my station is well within the footprint of the satellite. Then I'll show that it's on CW mode because beacon is in CW. I'm using fan dipole, HF fan dipole, which is 40 to 10 meter, because at this time it is most convenient to try that. Later I'll try, during a morning pass, I'll try my Moxon Yagi tomorrow. This is the G-Predict you can see here. I've already connected G-Predict to the SDR Sharp. I'm using RTL-SDR block V4 and this is the nominal frequency 435.605. The mode has been chosen as mode U beacon. There are other modes which can be chosen, mode U, VU transponder, but I am trying to hear only the beacon because I don't expect many stations on RS-44 in this region. You can see that the radio is being controlled. It's almost near the time of closest approach because these two frequencies are nearly matching, but I can't see anything on the waterfall, so that means nor can I hear any CW signal. You can see that it has reached past the closest approach now. I'll have to update my TLE, that is what G-Predict has informed me. I have not used this for a few days, that's why the TLE has been, that is 2-line elements, has become a little out of date. But that's not too many days, only a few days. RS-44 is an old satellite that was launched in 2019. I don't expect the TLE to become so much outdated. So I presume that I am right on track. But I am not very confident for this antenna because this is an HF antenna. As it is a night pass, it is not convenient to try the Moxon Yagi. I have to go to the terrace and rotate. It's not very convenient at 9:30 at night. And moreover, there was some rain also. Terrace is likely to be a little slippery and the vision also may not be that good. can see that it is at 36 degree elevation, and azimuth is 70, but I am not bothering about azimuth because it's a non-directional antenna, and this has a higher footprint than International Space Station. That's because the altitude is quite high. Technically, this is a low Earth orbit satellite as the orbit is below 2000 km. But compare this 1328 km altitude to that of space station, which is only at 420, much lower down. So as the satellite is higher, naturally the footprint will be more. But for me, that's a disadvantage, because even though both space station and RS-44 are having the same power of 5 watt, when the satellite is at a higher altitude, I won't get equally good signals. You can see the footprint of RS-44 here, and you can compare the footprint of ISS space station here, which is much smaller.